So one of the cool things about being an academic once you're tenured, right, is that you can do whatever you want, sort of. But you do have to get money to do it. So there's this little conundrum is like, well, but you don't know anything about that. What is this wearables thing for us? So you have to sort of figure out ways to, make your way and make it happen. So what I'm going to talk about today is social rationality. How do humans as a species survive? I mean, presumably rationality means you sort of know what you want, know how to go get it, right? That's a sort of, back of the envelope thing. And sort of obviously we have done pretty well till now because we're here, right? And yet we face a lot of challenges. Global warming, this, that. I mean, you can name all these things. It behooves us to understand how we as a species can make better decisions. And that also means organizations and individuals and want to understand, what's going on. And that actually is sort of a question about, how did our minds evolve and what are the problems that biology faces? There's very sort of basic things that cut across a lot of fields. And so I'm going to be risque and sort of venture out a little bit into those things. But the tools that I use for this are computational social science. Basically means there are now data resources for human behavior that are extensive. Millions of people, different sorts of behavior. You see this online. Most people do Twitter and stuff like that. But you can have access to lots of other things too if you, sign away your firstborn that you will never leak data and you respect privacy and things. And privacy is incidentally one of the places where I've been probably most influential because I helped form the discussion that led to GDPR, right? So that's good. Not enough, but good start. So we're going to be respecting privacy. We can ask about it if you're interested. But what I'm going to talk about is what all this data says about humans. And I think that when we think about humans and design computer systems, we make a lot of fundamental errors. And I want to talk about those. This is the emperor has no clothes sort of thing. So let's start there. So first of all, why are we a social species? You hear this, right? And incidentally, almost all the models that you see in computer science and other things are rational individuals. Those aren't social. Those are individual, guy who lives up in the Maine forest in his, in his shack and thinks, or Thoreau, except Thoreau, did you know that? So Thoreau, Walden Pond, all that, he had his mother do his laundry every week. It's okay, well, that's it. Anyway, it wasn't really isolated, but so it would be good to know why we're the way we are in terms of survival and fitness if we're going to design systems to make us more fit and help us survive, right? And of course, there's lots of reasons that you hear about, greater rate of cultural evolution. We can trade ideas and invent things, have them spread. But I think that one of the things that people miss is there are some fundamental mathematical structures about this that we don't often think about. And I'm going to talk about those a little bit, okay? So for instance, long-tailed distributions. So we all know what a Gaussian is, right? And you know what log normal is, has that sort of longer. There are things that are more long-tailed than that. And just sort of an illustration of that is like this, right? So there's the Gaussian, and then there's a fat tail. No big thing, we'll just fit it with a Gaussian, right? Except that with a fat tail, you get things that are, well, they're not quite black swans, they're gray swans, okay? So these really unusual things pop up. And they're not in our models because we're fitting things with Gaussians or stuff like that. For instance, after the 2008 financial crash, one of the senior people, the head of Lehman, said, this was a 26 standard deviation out event, right? It's BS, okay? 26 standard deviations is millions or billions of times the lifetime of the universe, right? No, he had the wrong model. And if you look at black shoals, the thing that they were building derivatives with, it uses concentrated distributions. It does not admit for long-tailed events. And they got hit by a long-tail event, which was part of the distribution. Because with these things, if you sample from this, typically what you'll get is something that looks like a normal distribution. You can fit it with a normal distribution pretty well. There might be one outlier. But if you do it again, you'll get a different mean and a different variance. If you do it again, you get a different mean and a different, because actually the distribution is very wide. Okay, so you fit it. This is a major source of failure of generalization in AI and machine learning, is you fit it, you get something, oh, that was great on my sample. The next sample you apply it to has different statistics because it's long tail. The sad thing is that almost all preferential attachment processes and all cascade processes read almost everything social and everything biology are one of these two. Right? You understand what that means? Everything you look at is not Gaussian. Not everything, lots of things, okay? And what that means is that this nice little notion that I can sample the distribution and do, a t-test on or something is wrong. So this is a nice little diagram a friend gave to me. So if you're going to use the statistics that all of you use, right, like most machine learning stuff, right, and you've got a thought-tail distribution, you're going to be in bad shape. You are not going to get good generalization. Okay? Now, if it's mixed, you do quite a bit better. But if you had the right statistics, you could do lots better. Okay? So that's interesting. And you see this in some science, like in medicine. They do these very expensive randomized control trials, right? And then they don't pay attention to them. They do another one, and another one, and another one. Why do they do that? So they can do a meta study, right? And it's only when you see the meta study that they begin to really believe it. What's that about? I thought randomized control trials were a gold standard. Well, except for confounders and except for long-tail distributions. Oh, you mean like all those biological processes? Yeah, okay. So meta studies have polynomial more samples. And when you get large enough samples, then you really get a characterization of the distribution. And the stuff you do can be meaningful and generalized. Okay, so that's like, okay. Maybe that's part of why we're social, is that I can't do enough experiments, right? Like I can eat blueberries and red berries, and I find the red berries make me sick, but that's not all red berries. If I can observe a lot of other people, I can figure out that, hey, red berries tend to make a lot of people sick. Don't eat them, right? Blueberries are safe. Everybody eats them. I don't see anybody throwing up later. Okay, good. Social. Social is very powerful for this sort of stuff. But, of course, that's not how we model humans in most of these systems. We model them, sort of Bayesian decision makers, maybe limited in various ways, right? And that's sort of the fundamental thing that you get in economics and all these sorts of stuff. And a lot of our political systems are this way. We assume that people are rational individuals. But that's a problem for a number of reasons, right? So one thing is, I just talked about, the real world has cascades. Rumors, panics, financial crashes, biological pandemics, all of those things don't admit very well of this type of model. You need to concentrate information from lots of people to get the evidence that you need. Okay? So that means you better pay attention to other people, and your math, your reasoning, had better be long-tailed rather than short-tailed. Okay, that all sounds very academic, I know, right? But it matters, okay? The other thing is, most of the way we reason, all the way we reason, is the past. Right? This worked in the past, so it's work in the future. How many of you have ever invested money in anything? And what does the little thing say at the bottom? Past performance is not indicative of future results or something like that, right? Yeah, it's not. The world changes. So what you need is something that's very efficient use of data to be able to keep up with the changes. There's no way to anticipate the future really well unless you know the generative processes, but what you can do is you can have something that updates the distributions and the decisions you make constantly so that you can deal with things pretty well. And you see this in signal processing all the time. People know what Nyquist limits are. So this is like, the people who are doing electronics ran into the fact that things changed too fast and they screwed up really badly, and they characterized, how fast you have to update in order to deal with changing signals. Look it up if you're not familiar with it. And of course, in this rational decision model, there's this notion of how do you integrate collective experience into the decision. Now, there's a lot of models about this, but people don't really understand collective representation and collective decision making. And I'm about to tell you a lot of what I think is going on, okay? And this is where I'm sort of getting out of my swim chart. So what I want to do is expand this rational decision model to include continual acquisition of both individual and collective knowledge. So I'm saying, no, we're not going to say, here's what we know and we reason and blah, blah, blah. No, we're going to be continually trying to figure out what's going on. And the way we do that is this. You'll recognize this, it's a Bayes formula, all that wonderful. But in behavior, this is known as foraging. So most animals have foraging behavior. What that means is the rabbit comes out of his hole, goes eat some berries. But sometimes what it does is it tries to find other berry bushes, even though that doesn't feed it, right? So there's exploration to find other food sources and exploitation to keep yourself fed. It's called the exploration dilemma, and it's part of trying to figure out what's going on in an uncertain environment. And so really what this move is about is saying, look, we live in an incredibly uncertain environment. I use this computer all the time. I'm pretty smart about it, but I don't know lots of what's going on in there. What I have is a bunch of strategies for dealing with it, right? That, are sort of an explanation, but if you push me, I don't really know. And when you get new releases of software, I figure out new strategies and I pull my hair out and stuff like that, okay? So it's not like we have a knowledge base or reasoning what to do all the time. Mostly we're just trying to figure out how to get along. That's the attitude. And you see this in animals. You see it it's called Thompson sampling or distributed Thompson sampling or distributed bandit problems. People know about bandit problems? Okay, bandit problems are fun. So imagine you go into a casino and there's all these one-armed bandits. Those are slot machines. That's where the name comes from, okay? And, they pay off different amounts. So this one will pay off lots of money, right? This one won't. But you don't know that. They're just a bunch of machines. So you have to try them to find out which ones pay off best. And that's called Thompson sampling. It's a Bayesian process of exploration and exploitation. You want to make as much money as you can. You don't want to pull the wrong arms. But you have to explore because you don't know anything about it. And distributed bandit problems are you're watching the other people. You say, hey, that lady, she's making a lot of money over there. And when she walks away, I'm going to go over there and try that one. Right? So I'm integrating knowledge from a bunch of people. And what I'm suggesting here is that as opposed to behavioral conditioning like animals or cognitive reasoning like individual reasoners, that's more like us. We're just watching what's going on and trying to figure out strategies that get us what we want. It's a more modest view of human intelligence, let's just say. But it's integrally social because you're watching other people for evidence. So what you're doing here is there's individual rationality, probably limited. I'll show you a little bit about that. But there's also a prior. And in humans and in many animals, this prior comes from observing other people. And like they ate the blueberries and they didn't get sick. Blueberries are good, okay? Right, that sort of a thing. And you can see that that's something that we do. These priors are essentially norms of behavior. They're the elements of our culture. It's the habits we've developed as a collective. They're our collective knowledge collective wisdom people talk about. There's all these sort of informal terms, but it's things that you can learn from other people to keep yourself fed and not get hurt and stuff like that, right? And that acts as a prior on your decision making. So if you don't know anything about the situation, you turn to the prior. You just do what other people do. When in Rome, do as the Romans do. If you know a lot about it, like you're an expert about this thing, then the prior, maybe you'll use it a little bit, but you actually know enough about this to be enough personal experience, enough observational experience that you can sort of reason it out. And so people have this fluid way of going back and forth, and I'll show you that. And what that gives you is a posterior which generates which action you're going to take. Okay? Now, some of you, very few of you, remember things like Shaky the robot and strips. So these are early AI things. It's basically trying to find rules that in this context, this rule works. That was a lot of early AI. It's sort of an action-oriented expert system type of a thing. Anyway, you don't care. So this type of model has rationality in it, but it's also continually learning and integrating other people's experiences. And it's not primarily a deductive model. It's not like representation and knowledge so much as strategies for getting along and accomplishing things, context-sensitive strategies. Okay? So let's think of this. Often this is called try-buy. So you try things. If you like them, then you do them again and again and again and again. That's the exploitation thing. So this is actually 10 to the 8th people's credit card records. Be afraid. No. This is done inside one of these big banks where we could look at their data and try and understand. And what you're seeing here is that what people do is they go to a few places and they buy things. Those are those big things, and they tend to return them. Those are the big arrows, right? So you think of this as a Markov model. So, get up in the morning, you have your coffee, you go to work, you have some more coffee, you go to the supermarket, that's number 5 every once in a while, and then you go home, right? So those are the things you do. But you also do these other places in your environment occasionally. And you can see when somebody moves to a new place, they do a lot more exploration because they don't know what's going on. And some of these things out there that you try will become the go-to places. And other ones will fall off. So what you've got is this continual exploration process to have exploitation of the things that you like, and that evolves over time. And everybody does this, right? This is the universal pattern. When you get to be really, really familiar with places, you don't explore as much. You see this same behavior in bees and other social animals, right? They go out and they try things, and then they settle into a pattern, but they continue to explore some. It's a little bit like, for those of you who are more math-oriented, like MCMC, Markov chain Monte Carlo, because you have lots of elements out there doing these, Markov chains for exploration, where what they're doing is updating their transition patterns over time. And you reach an equilibrium as a population for which things are useful to the population and which things aren't. In other words, if something's very popular, right, that means lots of people in the neighborhood, through their exploration process, found it to be good, okay? And in fact, this process has been supercharged in most social species. Like in bees, when the bee finds a lot of pollen, it comes back to the hive and does this waggle dance that tells other people where the pollen is, and then more bees go out, and they all come back, and they do this little waggle dance, and then you got more bees. And if there's enough pollen there, what happens? The whole hive picks up and moves, okay? You see the same thing in ape troops. So to figure out where to go, they all sort of like hoot at each other for a while, and then eventually one group wins the hooting thing and they go off that way. And we have Yelp, okay? That's a joke. But what that's interesting is this is a sort of a collective judgment about which things are good and which things aren't, right? This is, I would claim, a version of collective rationality. For the population in a region, The things that are popular are the things that the people like. That's sort of duh, right? And they find it through this exploration process. So if a new store opens up, it has the possibility of joining the best list, but it depends on people visiting it and then deciding that that's going to be a go-to place. Because I just want to show you that because sometimes it's a little hard to understand this stuff. So in recent years, we've been working on the math of this. And so what you've got is you've got all these agents trying to figure out what's best for them, right? And they talk to each other and they observe each other. Okay, but that observation is noisy. Sometimes what you like isn't what I like. So you have to decide who has the same utility function as you. Because if you like the same sort of coffee I do, I'm going to watch where you go and follow you. And you have noisy communication because language is not actually about the truth. It's about sort of what's on the top of our head and so forth, right? So we have developed things that are very much like human behavior. So you get bad guys in there, you get people with different utilities, you get noise, still converges to this optimum. And the part that's really different is this sort of business of exploration and learning from each other. You can prove optimality. Optimality in this sense is minimum regret. So you waste effort the minimum amount of time. Waste effort on bad arms, bad choices, the minimum amount of time, both as an individual and as a group. So that sounds like preservation of the species to me. We've got a certain amount of energy, a certain amount of choices to make, a certain amount of time. You want to make the best choices you can. You have to explore because you don't know much about what's going on and things change. Here's your optimality proof. Okay? Worth paying attention to for that reason. You may disagree with me. That's great. But most of the models don't come with a sort of quote unquote fitness optimality. And I'm waving my hands a little bit here, but just a little bit. So pay attention to that. Interestingly, you can make this robust to those long tail things. So I mentioned at the beginning, why be a social species? Well, because you have all these cascade processes and you have preferential attachment and it's just going to screw up your reasoning. You can make this so that it's robust to that. And it's optimal up to Nyquist limits. It's optimal for changeable distributions. You don't have to assume equilibrium. Right? So a lot of the things people assume in these things, like it's all stable. Well, BS, right? It's all sort of compact distributions. Yeah, well, sorry, no. A lot of the things that people assume away and are responsible for our systems crashing and burning as a consequence, because we made assumptions that are just not true of the world, can be handled by this class of model. Sir?
Yeah, just a quick question. In this setup, do I observe the other's rewards, or are their rewards private to them?
You can observe, so the simple one is you observe the other people's rewards, right? You can observe aggregates of rewards and noisy aggregates of rewards, and noisy aggregates of rewards with people who are lying to you, and you still get optimality, but obviously there's limits to all of this, right? Okay, so that's just not bad, right? And is it a perfect simulation of people? No, right? But it's this sort of basic math is like saying, logic is good, and we can try to sort of describe things.
What happens when you have populations cluster, right? So when I don't have visibility into everyone, I may just have my local neighborhood.
Yeah.
And so that may bias my estimates and my observations.
You can get echo chambers, and even more, you select your neighborhood.
Right.
So what you select are people that you can learn from optimally, which are people that are like you, have the same utility function. So it enforces homophily. Homophily is a natural thing. But there's a contra thing too, which is that if you're going to really, once you get homophily, what that does is that everyone is doing the same things, so you don't learn as much. So there's a real payoff to observing people who aren't like you, even though it's noisy.
Right.
So what you get is you get this block stochastic structure, naturally emerging, where the value comes from, a lot of the value comes from observing people far out, but those are very noisy signals. And then there's the sort of local portfolio of decisions that you make that you've vetted with people who are like you.
And when I'm minimizing regret, is it each individual's, or is this some notion of like the collective's regret?
And interesting thing is, it's both. That's like, wow, really? So it's a collective, but for each individual, it also has an optimality. They're slightly different optimalities, but yeah. That's really interesting. So it's a good strategy for you, but it's a good strategy for your tribe also. Yeah, it's interesting. So look at it. I mean, you know, I'm speaking English, so that means it's not the math, right? Okay, so look at the math. So I'm taking long here, I apologize. So in the psychological literature, there's this guy by the name of Kahneman and Tversky. They won a Nobel Prize for decision theory, and they talked about system 1 and system 2. So do people generally know about that? Many people do. Some people do. Anyway, so system 1 is supposed to be like this automatic thing that's sort of like simple rules you apply, and this is actually the vast majority of your decisions, right? What you wear, where you go, what you drink, what you eat. You don't think about it after a while. It's just built in as this little routine. And then you have a reflective thing, which is the conscious mind, because this is mostly unconscious, this is system 1. And then system 2 is this sort of reflective logic. Think about it, is this really good for me? We were talking earlier today about quitting smoking. Once you started smoking, it's all system 1 stuff. It's like you feel this, you put the thing in your mouth before you even realize what you're doing. And it's really hard to stop smoking because system 2 and system 1 don't talk to each other much. Okay. Now, there's a lot of reason to believe that this is really good, got a Nobel Prize, all that stuff, but it's probably too much of a cartoon because those things do talk to each other. Incidentally, system 1 is the social one. It's about norms, copying other people. System 2 is much more individual. So there's that dimension to it too. So you can map this onto this exploitation thing where the likelihood of something given the features is your rational mind, right? And then that's that system 2 that's slow, painful, you don't use it all that often, blah, blah, blah. We go to university to learn how to do it. It's not a natural thing. And then system 1, which is the thing that, like, you know, 4-year-olds have and 5-year-olds have and stuff like that, comes from social cues mostly. And those social cues, therefore, reflect the common norms in your environment. And you'd like those to be collectively rational. You'd like them to be true in the sense of being helpful to your fitness as a tribe, just like you'd like the individual rationality to be helpful to you to survive, okay? And then you get the posteriors. So this is something one of my students, Ziv, who's like a superstar type of guy, did just recently. He built a social media platform where people would doom scroll just like they normally do, but he would measure how much you dwelled on things, like how long did you pause or spend on something, and then whether you actually dove into it and like read the article, that type of thing. He did it with images and did it with text. And what you find is this tri-stage, which is like you're doom scrolling and you're trying to decide what to actually look at, right? Is very much sort of stage 1-y type stuff. And it's focused on sensational things, but it's not attentive to credible posts, the credibility of the post, okay? And it is very influenced by social things. On the other hand, the buy things, the ones that you put in on, are much more focused on credible things and not sensational. So there's some good news there. So what he's found is that if you get people to pause before they forward things and just sort of consider credibility, so they don't just forward things because the title's cool, they actually look at it first, and then, only then they forward it, they do a much better job of avoiding fake news. Interesting, but here's this try versus buy. You're exploring what everybody else is doing, and then you're selecting things, and you only like really spend energy on things that you find credible and useful, okay? Or, for instance, Music Lab. People know what Music Lab is? Okay, so Music Lab, people made a bunch of fake music worlds that had social feedback or not social feedback. And what we found was that, again, this try-buy architecture, people would pick things based on the title and the social number of sort of people who had looked at it and so forth. That was very perfectly predicted which things you would sample. You'd listen to a little bit of it. But the ones you would actually download were individual. It was based on things that you liked. And this is rather also like visual search, which is, we can scan things and pick out certain things amazingly well. Like this is Find Waldo. Do people know that? I know, it's a generational problem. It's like when you have little kids, you try to find Waldo, right? It's a little stripy character in this messy thing. We're actually really good at that sort of stuff, appallingly good. But then understanding what to do with it and taking action based on that is a much slower process, right? So again, it looks like this try-buy thing, which is, right, okay? And we do the same thing in more complex situations. So this is a platform that we've focused on a lot. This is eToro. It's a social trading platform. So you can buy and sell stocks and stuff like that, right? But you can also see what other people's strategies are and how they're doing. So I can say, oh yeah, she's long on the euro and short on the yen or whatever, and she's doing really well, okay? Now, I don't know how much money you put into this thing, but I can see how much she did in the last week or last month and things like that. So there's this sort of social feedback. And then there's your own, like, what am I actually going to put my money in? Because it's real money. Typical money is on the order of 10,000 bucks. It matters, right? Okay. And what we find is that this notion of what people invest in is really extremely well described by this distributed bandit foraging, distributed Thompson thing, where it's popularity literally times performance in the last little while dictates the posterior, and you construct a portfolio based on this posterior. And that's what actually across hundreds of thousands of people all around the world is what people do. So what they don't do is they don't make decisions based on the properties of the trade itself, okay? So has this been a good trade recently? What they do is has this been a good trade recently, and do lots of other people do it too? And that predicts what they do quite accurately. And there's a nice paper in Cognition about this. Where is that? Yeah. So Bayesian collective learning emerges from heuristic social learning. So we're very limitedly rational. These are very limited sort of individual things, but they are collectively rational, which means that the group of people actually have something that is very near optimal investment strategies, portfolio. Think about it, a bunch of idiots out there like day traders gambling their money. Individually, they're okay, they make a lot of mistakes, but collectively, they're really good. Interesting. And the other sort of stupid thing is that people don't follow the collective as much as they should, right? When they start off, they use stereotypes to guide their notion of social, and it turns out to be sort of bad. Like, you follow other people of the same nationality, or other people that are the same, some other sort of property. Anyway, you should read the paper. It's interesting. The key observations are these very simple heuristics about is this a good thing or not, plus social sampling, looking at the people around you, yields a collective rationality. That's pretty amazing, actually, if you think about it again, right? So it's good for the people because they feed that back into their decisions. But it also suggests a lot of things with human-computer interface, right? Which is nominally what this is about, right? So, like, for instance, to improve in performance, you could do better risk management. You could cue people that when they choose a posterior, they should pay attention to the risk. You could have them use better features for their personal estimates, for their System 2E sort of thinking about it. People resort to stereotypes too often, and that hurts their performance. You could help them by giving them tools to make better estimates, so sort of showing them what happens. You could do better sampling of the social situation. Better sampling of other people tend to not choose other people to learn from optimally, okay? And you could give them help in doing that so that they don't choose a bunch of people that are too similar to them. Because remember, there's this tension between validating by people that are similar to you and learning new strategies from people who aren't similar to you. So you can give them a little bit of that. Let me just show you really quickly. So this is the number of people you pay attention to down here. Yeah, it's about 15 people, and your profitability at making trades. It's across hundreds of thousands of people for years, right? So people can pay attention. We're limited. I only pay attention to about 15 other people. And if you try to do more than that, you screw up, okay? That's interesting. If you intervene and you say, oh, well, those 15 people should be people with different strategies, okay? Not all the same, because people tend to say, oh, this one's good, and then they pick another one that's almost the same, it's highly correlated. So you're making the spread of their strategies broader. That helps. You can also do things where the machine pays attention to the different strategies and selectively adds a few back to people, right, to help them keep track of things. Perhaps by saying, oh, well, you should use this new one rather than that one that's too similar to the other ones because it's highly correlated. And you can get an increased performance that way. Just saying, if you want to make money. You can give better tools. So I talked about long tail distributions. So in these things, if you have a machine doing it, you know, what happens is because trading is stocks and things like that are cascade processes, they're preferential attachment, right? The rich get, you know, if it's they're meme stocks. Everything's a meme stock. Lots of momentum in there, right? Okay. So if you use standard methods that assume concentrated distributions like Gaussians, you converge to best strategies relatively slowly. But if you use math that takes into account the long tail, you can do very, very much better. And there's a paper about that. What that is actually is this, is when you get an outlier, you keep it aside. So, well, this doesn't fit the models I have, right? You keep it aside and you ask, are any of the models that I have actually long tail, but I didn't know that? So you keep a little index of weird stuff and you go back and you ask, each time you get weird stuff, could this actually be a distribution that's not a concentrated distribution? And if you do that, then you discover those long tail things fairly quickly and your estimate converges really fast. Okay? So it's not really, it's sort of you can imagine humans doing this, tell stories about the weird stuff, just so you recognize that things can be strange sometimes. Who knows about the Great Flood of California? It's a fun thing. So in 1862, the Central Valley was under 30 feet of water. Think about that for a minute, right? Because the rains were so dramatic that they couldn't rain fast enough. And apparently this happens every 100, 150 years. Normally, right? Over historical time. So don't buy things near sea level for another reason, right? Go up on the hill a little bit. Anyway, you might say, okay, so the stuff I've shown you is about regular people, not experts. So we did an experiment with experts. Those of you who do social science will appreciate this. We got the experts to pay us lots of money to be in the experiment. Okay, we called it a class, right? And they paid money to be in the class. And one of the things we did was an experiment in the class. And what we did is we asked, these were mid-career financial traders, experts, 40 years old, trade hundreds of millions of dollars. They know what they're doing, right? And we asked them to predict future prices on various asset classes. Okay, and we gave them the price history, and they know these things, and then they made a prediction. And then we showed them what everybody else did, okay? And asked them, would you like to change your prediction? So we showed them the social prior, and they were really, really good at the individual logic, okay, because they did this for a living. So what do you think happened? I'll tell you what happened. So the people who used the social made less money. Well, that's weird. Not a lot less money. We're talking about like 0.5% there, right? And the people that were all quant did a little bit better. So what's going on there, right? But if you look at it slightly differently, which is actually the correct way to look at it, which is risk, right? So yeah, you do better, but sometimes you blow it really badly. So actually in trading, having started a couple of hedge funds, I know this. You get killed by things that are unexpected. It's not like that you can make a little money each trade. It's that trade that loses 50% that kills the whole thing, right? So what you find is the people that are more social have much less risk. And so over repeated trials, they're going to come out better. So they trade a little bit in the present for the long-term aggregation because they never lose that 50%. Right? And it's interesting. This social prior, as you commented, is affected by your preferential attachment, the people you pay attention to. So if you look at things and how popular they are, you can come with problems. You can see problems in the way we think. Like I'll do this real quick, but I'll show you the interesting thing. So demand, supply. So how many of you take like Econ 101? Fun with linear functions, right? That sort of thing. So as the price goes down, the quantity of stuff goes up, and people begin to manufacture more of it. But if you're in a regime with preferential attachment, in other words, people speak to each other and say, oh, this is really good, and recommend it, the way, say, online social markets are, what you get is you get a very different thing. Because now the prior for your decision is changing as a function of the popularity. So as it becomes more popular, you're much more likely to buy it in a nonlinear fashion because of the social popularity. And of course, the same thing happens with the suppliers. They think, oh, this is the next big thing. We're going to make a lot of it. And it takes off. That has implications. So this is a recent paper. So we looked at various markets and how the big guys versus the little guys work, right? So this is a little hard to see, but so vertical there is your rank. So the 500 are the little guys you've never heard of. The big guys are like Amazon, Meta, things like that, okay? If you have random perturbations in there, in a preferential attachment thing, turns out the big guys barely budge. They're not affected about that because they have lots of people attracting them. Now the people, so they're very robust in staying there despite turbulence in the market. The little guys tend to get better because they can't get worse, right? And they get little bits of punch from preferential attachment. It's the guys in the midterm, sort of the B round or C round, that get slobbered, right? Because they don't have enough popularity to resist random permutations, okay? Oh, this sounds, so this is what I just showed you. I'm doing this quick. But here's real data. So Amazon, these are popularity of things on Amazon. The most popular ones hardly ever change out of being the most popular one. The ones that are a little less popular have real probability of decreasing. So unless you're the leader, you've got real problems. But if you're a little guy, you'll tend to do better. Okay? I know these are a little hard to read. But here's the interesting thing, is that we had a paper in Proceedings of the National Academy of Science showing that if you make this inequality in preferential attachment big enough, so it's a very strongly preferential attachment, then you get market domination inevitably, right? So when most people are not all that good at advertising and don't have that much mind share, but a few people do, they're guaranteed to become completely dominant in the market. And if you take one of them out, one of the others, the number two, just replaces it. So getting rid of Meta isn't going to fix it. There'll be a number two that comes in there, okay? Where you get good performance, I don't know why this is not showing up quite well. Let's see if yeah, here we go. Where you get good dynamics, the sort of competition you like to see, is where the different competitors are more or less equal in their mind share, in their attention share. Right? So that's the thing you should focus on, not market share, attention share. And in that case, you get competition. So I'm going to quit there. Sorry I had to rush that last little bit. So taking this sort of strategy exploration as opposed to individual rationality approach allows you to integrate the social and the individual, and actually describes a lot of phenomena that we see in a much more integrated way than other ways of approaching it. You can get collectively rational performance out of very limited actors, which is good for us because we're limited and we'd like to be collectively rational. But you have to be very careful about this because you need good social sampling to do this. And bad social sampling is called marketing or people who dominate Twitter, right? So those are things that make you think that something is very popular, so you look at it more seriously, and that causes a lot of the problems because it distorts your judgment, right? Because you think everybody else. ISIS used this just incredible ways to get people to go to Syria to get killed, right? Just in ways, they manipulated it so that these poor guys thought that everybody was going to Syria, right? And so they did, right? And the same thing with October 6th and stuff. I mean, it's just crazy. Experts use the same strategy, and in fact, they achieve what I would think characterize as a Pareto optimal strategy. So they're mixing social for risk control, but they're individually quite good at deciding what to do. That doesn't mean they can't do better. Like, for instance, showing them long-tail distributions will improve their performance. Showing them other sort of strategies will perform their performance. So even with experts. And so the final thing is that in a lot of these things, you have to be really careful about the social prior, particularly the sampling. What is the audience that people are reacting to? Because that inevitably influences the decisions that we make. Okay, so good, thank you. And I left 7+ minutes, which is not quite enough, but.
Yeah, we have a few minutes left for questions. Please go ahead. Do you want to go?
Oh, yeah. Thank you for the wonderful talk. I have a few clarification questions. So you talk about this like trying to buy framework.
Mm-hmm.
And then in the social media context, is it reasonable to think about that even the try stage is already like some sort of buying behavior? Because on social media, if I'm willing to look at the post for 1 second, it means that I'm engaging with the content. It's already like a buy behavior versus the buy metrics you mentioned, such as like or tweets or whatever. That's more like the second level.
So obviously that's a sort of a gray thing. So
Yeah.
in the music lab thing, you got to look at things and you could hear a little bit of the clip, but the buy was I'm actually going to download it so I can listen to the whole thing. So it's sort of distinct, but yes, clearly. In the social media thing, you're scrolling through, your normal, standard-looking social media thing, and it's a question of which ones do you stop on for a second. So it's a type of buy, yeah, sure, but you're not actually clicking on the thing. You're just like, is this something I want to invest some time on, right? So you're trying it. So try has this notion. It's like when you go to a new restaurant. It's like, I don't know, let's try it out. Well, you're committed to actually paying the money and eating things and so forth, but you may never go back. If it buy in this case would be, I'm going to go back and back and back, right? And the point of all that is not to make this such a dichotomous thing, which is the way it's described in System 1, System 2, but it's really this continuum of exploration to find better strategies. And you need to invest some in exploring, and you get some losers in order to come up with things like that. And when you include sociality in there, people with similar utility functions, then as a group, you can come up with a set of strategies that it has this optimality property for the group. And I'm not saying optimality doesn't mean it's like the best of all possible things. It means that it's a minimum regret strategy.
Clarification regarding the social and the rationality, and also the system 1 and system 2. I like the fact that those two systems talk to each other, but I still found sometimes it's really harder to say whether something is more like system 1 or more system 2. Like the restaurant example, I go to a restaurant because there are a lot of people waiting in the line. I know it's great. So
Kahneman and Tversky put out the System 1, System 2. It's a very popular framework. There's a lot of criticism of it that, in fact, they're not separate. Okay? So, for instance, the System 1 stuff shades into System 2, as you're just pointing out, right? They're really not distinct. System 2 is not entirely individual, because you have this sort of, well, but if I do that, she'll think that, blah, 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 sort of stuff. System 1 is not entirely social norms. That can be idiosyncratic. You know, there's a lot of evidence, though, so what this is trying to do is say, no, actually, they are part of the same system. And the thing that ties them together is this exploration, exploitation. So when something is really clearly in the exploitation thing, you've done it a bunch of times and so forth, then that looks much more like System 1 stuff, right? Yeah. Sir, and then you.
Okay, I'll be fast. Okay, I take your point to basically be, you know, we pay attention to each other. Good. That actually can produce some great outcomes. But we don't always pay attention to the right people. Bad. Right. That can sort of knock us out of the right equilibrium.
Yep.
And I think your point to be basically what we need is broad social sampling if we want to avoid that problem, especially on that last project you were talking about. So that means that we essentially have to reduce assortativity, right? That we have to kind of be listening cross-partisan in some sense to get those signals. But that's not individually rational to do, due to things like social acceptance and other kinds of, like, there are incentives that sort of keep us assortative, right? So I'm curious if I just give you a soapbox for a minute about what kinds of shifts to sort of, you know, the environment, the design environment, our individual psychology would produce those kinds of outcomes more often than we see them today. I'm thinking in particular here, I've been spending so much time thinking about social media recently. You know, there's such an individual incentive to be assortative. I don't know how we, you know, what shifts to the environment would actually undo that.
So words like optimality and minimum regret are a little tricky in this sense, right? So given the situation, this is what your group will decide is the right strategy, okay? So that is your judgment, and given the evidence that you have, it's probably pretty good, according to this. However, the group and the information you have could be all screwy, okay? And if I can give you additional information, this trusted information, about the situation, then you may shift your strategy. So what this is saying is I'm not telling you what the new facts are or old facts or any of that sort of stuff. I'm not making an argument from logic. I'm making an argument about what strategies are likely to be good for you. I'm not telling you about that. I'm going to let you decide, but I'm going to give you, basically I'm telling you, the game that you're playing is not the right game. Here's some other things you haven't considered. Let me give you an example. So if you go in and you ask people, like the people in this room, about what the right wing thinks about undermining democracy, where this is like strongman versus elected leader, they think that the right wing guys are like all about autocracy and stuff like that. But if you ask the right wing guys about it, right, in a neutral thing, like Pew Charitable Trust sort of people, these are the real opinions. Dramatically wrong, okay? And so one way to think about this is that what the press does is it highlights crazy people, right? That way you'll read it, right? Okay, so it's nut picking is the phrase that people use. Interestingly, and you guys won't like this, this is the right's belief about the left opinions. Oh, sorry, you didn't like the previous one. This is the right's belief about the left opinions. The left opinions think that you're a bunch of, the right people, right-wing people think you're a bunch of crazies, okay? But if we actually go in and ask you, there's your real opinions about undermining democracy, okay? You will notice that those look very similar, okay? That's not popular in this room, okay? But this is 5,000 people, and it was just replicated here at Stanford in comparison of 140 different strategies about how can you reinforce democracy. Willer is the guy that ran that. Same results, right? This was also the sort of the top, or one of the 2 top performing strategies for this sort of thing. So if you show people this, if you have just a little online thing saying, oh, actually, no, actually, the people on the other side have these beliefs, concrete things like willing to do suppression of the press, things like that, very concrete things. They actually change their voting behavior. They actually change their voting behavior. It was like a 5-minute intervention. You can go see it. It's online, right? That's amazing. So what you're doing here is you're giving them data about the situation that they hadn't seen before, and it causes them to change their strategy. Now, they don't become 100% the other way, but they do change their opinion and their strategy quite a bit, and it lasts for at least a couple of weeks. So that's interesting. And I think that this is a little bit like those experts, those financial experts. These financial experts have been doing this for 20 years. They handle hundreds of millions of dollars. They know what the heck they're doing. But when you say, oh, by the way, all the auto traders are more bearish than you, they'll say, maybe I should reconsider just for sort of risk control. So the strategy that they pick is more like the other people, and they move a fair amount. In fact, the amount that the expert traders move based on social cues is rather similar to this. I mean, in terms of amplitude. Yeah, sir, ma'am.
So I had a question on the notion from, I think, like a couple slides ago of good social sampling versus bad social sampling. I was curious about how you might model trust into that model that was up there earlier of observing, neighbors in the community, observing their behavior. For instance, I might trust my neighbor more than I trust somebody on Yelp who has the same opinion, or I might trust
Sure.
a neighbor more than another.
So here's the data that we have about that, is that, first of all, you're more likely to trust people that share a lot of similar circumstances with you. So in particular, people who live near you and have the same policing, the same medical, the same this, because like all your decisions are shaped by sort of common circumstances. If you find people who pay attention to each other, so like I reach out to you and ask your opinion, or you reach out and you reach out to me, well, that means that I find your opinion valuable and you find my opinion valuable. When you take pairs of people like that and you ask them things like, would you loan that guy $100? The answer is yes. If you take people who aren't like that, the answer is no. And the accuracy of this is some crazy number like 95%, right? It's really predictive of trust. So what an interpretation of that is, and I'm not saying this like 100%. So trust is expected mutual value, right? When we trade things. Interestingly, there have been some studies recently that show that there's your homophily group, the people who are like you, but that people have these persistent long-range ties. So they're not weak ties. That's the traditional thing. You get new opportunities through weak. No, these are fairly strong ties, but they're long distance in the sense that they go to a very different community. And people hold on to those. And most of the sort of new things they do come over those. So that's highly correlated with wealth creation, better life outcomes, stuff like that. So it's interesting. So there's this tension between your in-group, the people who are like you, and the people who are not like you. And when you can form these trusted relationships with people who are not like you, those are incredibly valuable. What's the evidence? And they're persistent because you expect that they'll continue to be valuable, which I would take to be a good definition of the word trust, right? I know it's not the emotional subjective thing, but it's this, yeah, the guy has my back. There's like, they're giving me the good stuff, that type of a thing.
So it's like the trust is sort of inherent in the interrogation, like it implies
The reciprocal.
the reciprocal interrogation.
Right. So I mean, you can give examples like this. Like, you get up it used to be you get up in the morning, you go down to the newsstand, and you give the guy a quarter, and he'd give you the newspaper. And you can sort of, and if you showed up one day without a quarter, he'd give you the newspaper anyhow, right? So that's a trusted relationship. You may think the guy is an idiot, and you may hate what he stands for, but you have trust on that issue, right? So that's another thing. Trust is not like this generalized thing. It has to do with specific types of issues, strategies, values, stuff like that. Okay.
All right, I think let's thank our speaker.
Good.